so we are glad that we could support this. That's why we're here. So thank you very much for having me and having us. And so I will dive in. I need to go back a little bit. So the perspective is today, that's always how we put it at the beginning of the course, that we tell the students what they're going to learn today and what the outcome should be. The objective is to record an ECG, understand the major components of an ECG wave, to understand the temporal relationship between the electric signals that we measure to the pulse of the blood in the finger, and to interpret the cardiac cycle on a, let's say, very basic level. And I can show you later how much detail we do also in our research software. Maybe one thing before we dive into the lab. Quite often, you can see here they are both called hard and ECG. One is called pre-lab. What we always do is for each lab we have a little pre-lab, because normally before a student comes to a lab, they either had a lecture or went to a textbook or had a seminar with you. And this is basically before you let them do the experiment, they should do a little refresher. They should refresh their memory. So we're doing a little refresher of what they are supposed to have learned. And then also do some questioning to probe their memory and what they have learned, so they get the best out of the course. So they don't come unprepared. So we kind of force them a little bit to refresh their memory. I don't need to answer it. It's been 15 years or so since I last gave a lecture in university, so I'm starting to enjoy it again. Can you think, if you think of an ECG, what is it useful for detecting the following four? And I can, later on, the software has a free trial for I think 30 days at least, and all this content is in there. So if you want to have a look afterwards when you get back home, you can download it, you can see all the content, try it out. So you have it all, including all this background. Do you have any idea? What is the first one? Useful? Useful or not useful? Yeah, we have a discrepancy here. We'll discuss this again. Not useful. Not useful, this one, right? Let's keep it like this. Oops. And this one is easy. We'll discuss it in a second. Enlarged left ventricle. Useful. And arrhythmia. So let's just say the students pick this one. The one with the valve is a bit, you can argue both ways, but normally abnormal heart valves you more hear by the sound or so, or by an echo, but not with an ECG. But let's just assume the student did it like this. They'll get an instant feedback, and they can redo it and can check the answer. So easy to drag and drop. And also here, quite often you have if you pick an answer, you have, if it's incorrect, you have a hint that guides them to the right one. If it's correct, it explains a bit more. We don't need to go through all these questions, but you can have a quick look. It's basically probing some basic knowledge that you might have taught them. Okay. I'm pretty sure most of you know more about ECG than I do, but let's dive in and do some experiments. Maybe this one is a. Do you still remember from your university time how what an ECG is? Basically, it records the overall vector of an electric activity, and you have these two directions of don't remember it, you can still always have a look how it's done. So you add basically the end of one to the start of the other. So it's not both ends together, but then it's A. That's just a quick refresher to see, people see how the A is added. And it always puts a bit more. That's correct. The sum of two vectors can be found by adding two components, vectors tip to tail. Here it looks quite big. Actually, it's not that big. Just this little box. That's where all the magic happens. And you can see here that what you see here now is the biopotential one that we plug in here. And then you can record, it's in total 5 leads. We do 3 today for simplicity, but it could record 5 leads. Again. And the other one that we do is a quite simple device called a finger pulse transducer. Basically measures tiny changes in pressure. So basically your blood pumping through your finger is detected by this device. It's so sensitive. Just as a side note, I had once a customer who was doing research on bats, so the animals hanging from the ceiling in caves, bats, and she mounted this one to a plate, and when the bats were hanging upside down, she could measure breathing of the bats while they were asleep, just of these tiny little changes. That was quite impressive. So that's how we measure the finger pulse. And yeah, that's basically all it. Does anyone have Power Lab or teaching Power Lab?
Yes. Yeah.
Since how long? Is it still working?
Yes, we have one 2018.
So 15 years?
Yes, it's working this Sunday. But now also in my new lab.
I have no doubt, because we asked our customers what is the oldest still running Power Lab.
Both of them are working on lab unit. Still we don't have it.
Oh yeah. But yeah, normally they don't break, right? Maybe these things break from time to time. You know, the transducer, but this thing normally doesn't break. We have some customers have it like it's 30 years and it's still working. So it's hard to imagine these days where phones are old after 2, 3, 4 years, right? Yeah. That's how we set it up. Just go with this one. So, what we need is to record a ideally healthy volunteer. So we will record just go back to this previous one. We'll record it at the arms and the ankles, so you don't need to remove your dress. So do we have a volunteer who wants to see a recording? Oh, come here. I hope everyone can see it, so just plugging in the first one. So maybe your left hand finger, just a middle finger. Always when I hear photo clicking, I would do this way to get the belly in. So, well, does anyone a forced grip, or even I saw here some glassware for if we do like there's 3 sticks, like for an organ bath or something like this if you want to measure something. The right one that he's just preparing is used for bioamplifying or biosignals, so biopotentials, so EEG, EMG, ECG, EOG, so eye movement and so on. And these two here in between, the red and the black one, this is a stimulator, so you can basically stimulate the student by placing an electrode, let's say here, and stimulating the nerve. Green is left.
Green is left. It's not following the conventional colors for ECG, where right should have been red.
No, we have also a second channel. No, for the 12-lead ECG, I think we
Clinically, we normally red, orange.
Yeah, I know it from the silk paramedics time. Is it red, yellow, green?
Yeah,
Right.
exactly.
Yeah, just the left ankle.
Okay. So I stand this side. This side? Or good? I'm gonna be famous.
Well, just try to keep the belly in, not breathing.
I'm doing my best. Right.
Thank you very much.
Yeah, it's good.
So, just keep relaxed. And then we move on. And as I said, there's always anything that looks like a link is a link. So it opens a pop-up so that students can see more, can understand better. It shows you how to do it. So the idea behind this is we wanted to put in as much information as possible, but not overflow the students with information. But if they understood it and want to learn more, they'll find it. So that's the hope. Keep the arms really relaxed so you don't have any tension.
This is that kind of red.
See? It's okay. It's going a bit. So just record for a bit. One thing, if you don't get a really good signal, it's much better now.
Where I did you? Add some gel? You can add gel or?
You can add gel or first some abrasive gel to get rid of like old skin tissue and increase the conductance, and then of course with gel it becomes even better. But that's why we use the sticky electrodes. They have some gel inside. So let's just see, but it looks good.
So you mentioned 3 or 5 leads. So you don't have one that can record the entire 12 leads?
Sorry,
we cannot. Is it possible to record the 12 lead ECG?
I'll show later. We have so because it just has 4 channels and the bioamplifier here, amplifier here has only 2 channels. What you can do, we have, because there was always a balance, the more leads or the more channels, the more expensive the instrument gets. So we keep it simple there, and we have like a box where you can do a 12-lead ECG and then switch and not record all 12 at once, 2 at once and the next 2, so people can get the idea of the different leads and the different things. But if you want to really run a proper 12-lead ECG, then you need to go with mostly I think maybe clinical devices that do this. So for a proper 12-lead ECG, maybe that's a bit too much. But we can see later. Anything? Maybe one more thing. The device, of course, is human safe, so that it means it's electric isolated. So even if it's a thunderstorm now, where the lightning hits the building or so, he's safe. Probably not if the building collapses, but at least from the device. So, is there anything that someone with a bit more experience in ECG can spot in the ECG, but also maybe in the finger pulse? Does anyone realize some interesting pattern in the? Say it again. What was it?
The notch, well, depicted.
So here you can see this little dip, right?
Yeah, the notch.
The viscotic notch when the aortic valve closes, you get this little dip. So this is really you get this light fluctuation in the pulse wave, and the aortic valve closes. You get this little dip in the flow, so it's really nice to see. And then let's go to the analysis. It's taking the recording from now, and then we can start all the measurements that clinicians or physiologists or whatever might be interested. PR interval is the first one that we do in this practical course, where you from the start of the P wave till the QRS complex starts. Other things down here is the QRS interval itself, how thin or wide it is. ST interval. I'm happy that we don't see how do you call it, ST elevation. I've seen too many as a paramedic, so and so on. So we can maybe just do one as an example. Let's go with the PV interval. So from the start of the P wave to the start of the QRS complex. So we can easily do it by placing here this part. Let's say the P wave, I would say, starts here. Do you agree? Roughly. And this is where the QRS complex starts. 140, 150 milliseconds is standard value for this. And then the students are asked to put this into a table. So what you can do is you can either copy it from here, or you can just drag and drop it. And then it's in here, and you can do all these measurements to QRS interval, to the ST interval, TP segment, and so on. Probably for the sake of
milliseconds, which is in second is point.
So 143 milliseconds. So 0.14 seconds.
Okay, zero.
So it's milliseconds, 1/1000th of a second. Yeah. And then the next thing is maybe we do this measurement because it's this is, let's say, also an interesting one. We say when the heart starts beating until, and now we look at the bottom curve of the pulse wave. When the pulse wave here it starts, right? So 200, 220, 250 milliseconds is a good standard value as well. So what does this tell us? Now, does anyone have an idea what? I mean, the QRS is the ventricle contracting. The electrical signal, and then the depolarization followed by the contraction of the ventricle, right? And the pulse wave at the finger pulse is when it reaches the finger. So this gives us the information how long it takes from the heart ejecting it to the pulse wave reaching the finger. And we could even say that's, what is it, 1 meter maybe, divided by the time. You can even get a velocity of the signal. So, yeah, these are really some basic things you can teach them and can show them. We can also maybe if someone else want to volunteer, we can also do this. We have always in between some check your understanding, so that what the students just learned, that it gets, let's say, fostered. And then we would already come to the 12-lead ECG. I'm rushing a bit through. Have I showed you the background? Because I got a bit. Did I? No, did not. No, I didn't. I got confused with the other group that was shortly there and then left. So there's always. I talked about, basically there's a whole textbook in there. But it's not overloaded in the course material, it's in the background. So if students get more excited, want to find out more, they can go to background and find out all these details, read about it, and get different information. This is also one thing I really like, maybe one thing to mention first. All these lessons come pre-done. So we have done them. We also have example data. I can show you how to load example data if you don't have a machine or not enough machines. Or if you just want to show it without a machine, you can also load example data into your panel and do the analysis without doing it. You also can online change the courses. So if you have a topic that you want to change, or something that you want to remove or add, you can do it. And then you save it and it's available offline again. One thing I really like is this annotate picture. This is basically where you can ask people to draw on a picture that you uploaded. As an example here, draw where the 12-lead ECG positioning should be.
One question.
Yes?
Are you using the Pascal? Are we able to measure the heart rate variability using the?
The heart rate variability?
Yes. But you have to have its own software.
This is, I think, in the research software we can easily do it. In the teaching, we don't normally. Don't think we have a heart rate variability part. And now it becomes more and more
You have a
important.
separate research software.
Yeah,
Yeah.
it's called Lecture.
Yes,
Is
in
it
Lecture.
updated or is it same?
It depends on what you have. We have Lecture 8 now, and it has all the some modules, of course, with it, and we have an even newer one, Lecture Lightning, but that's more an early stage one. I can show you later. Let me just. And then you can check an answer with something you said before. You said this is the correct one, so the students can try and paste. And you can then basically double check if they did it wrong. I did it right or wrong. Let's switch to one more thing. At the end of each course, you can click. Yeah.
How can you explain how to measure the heart rate from the ECG we already did?
What? Say it again, the heart rate?
Yes, we did the heart rate of this person. Yes, in this.
We haven't done it here. I think there is. Interesting.
And usually data I will confuse.
We didn't do the heart rate here. We have another lesson called physiological cardiorespiratory effects of exercise. There look more at heart rate and breathing and so on. Here we really focused on the electromagnetic things of the electrophysiology of ECG and times. But normally you can easily do it. Normally we have done it in a handle, but I mean what we could do is we could say it's now 1, 2, 3, 4, 5 beats in 3,800 milliseconds, so in 3.8 seconds. So we could do the math and upscale and say, let's quickly do it, 5 beats. Let's say 5 beats divided by 3.8 is 1.3 beat per second times 60 seconds, so his heart rate is 79. So now I did it by calculator. We have other courses and other lectures where it's done more automatically.
And that one, the QRS complex,
Yes.
since the S complex is much deeper, that number,
Yeah, that's
We do on the scale.
He was different.
what?
We do on the scale to look at much more.
No, what he is saying, if you compare it to
It's different. The S is different.
S is
S
It's
is
different here.
normally it doesn't go down that deep,
it's gone down.
very deep, but I've seen it for perfectly healthy people going down that deep. I've seen the one volunteer before almost have any going below 0 of the S. It could also be, you know, there's a lot of cables and lead tube. Yeah. So normally it shouldn't go down that deep, but it could be just some replacing of the electrodes or the. Pardon? You don't need to do it here. There's no shifter, so in ECG. But I've seen it all ways of it going deep. But you're right, it's going deeper than, let's say, in the textbook. But it's nothing.
I think we can measure the volt and know if it is deeper or not, isn't it? We have such a facility. We can measure on the ECG the voltage and now.
Yes.
So, is it good?
I mean, you can see, I mean, here it's come from what is it, 0.5 millivolts upwards and also minus 0.5 millivolts downwards. It could sometimes also be that the signal in general, I mean, should we just maybe compare it to the second volunteer?
You're making the volunteer worry.
You know,
That's for the
He is
numbers.
perfectly healthy.
That was Maria. It's normal.
I mean, that's have you, I heard it from educators that said sometimes they found some, I mean, you're perfectly healthy, don't worry, but
I'll show you.
that people, that sometimes people found like severe heart defects when the volunteer is there and they see really something.
In doing that lab of blood pressure, for 3 consecutive time, we find when the student is high blood pressure.
Oh.
Again, it's for accidentally.
Totally.
So we just see, we measure, and then we ask her to follow and to diagnose hypertension.
Das bitte online.
So, but we have lunch between 2 and 3. So between now, so after this one, and then we may do lunch, and then we do the third one. Okay. Do you tell the others as well? Thank you. Yeah. So it's important to say this is not a diagnostic not for
Yes, yes.
diagnostic use, but sometimes I heard it from educators that tell this. Some students like, go check it. But this is perfectly normal. Sometimes it doesn't go. Probably it's not the downward is so high, but probably the upward is too small. It looks more like this. Maybe just if you can get water or something. I have enough to survive. Okay. Is there anything on this, let's say, more education course software that you want to dive a bit deeper? As I said, we could do another measurement with another volunteer to see some differences. 2 volunteers on ever. The same? You want to do it?
I'm doing 8 also.
No, I think it's other.
So sometimes when people wear watches or metal things, let's see. I mean, we could keep it on and we could see if it makes a difference. But sometimes it makes a difference if like a metal arm, like a watch or so, is on the wrist. So also, oh, yeah. What did you get them from here? Okay. Just there. Perfect. Is there anything particular in relation to ECG that you're interested either from a research point of view or education point of view? Just put it down as relaxed as possible, because when you hold it, the tension of the muscles might interfere. God, thank God she's alive as well. Now you can see some laughing. That's good.
It's better.
And you see here,
Yeah.
the going down missing, right? It's just, there's almost no one has the perfect textbook ECG, which means probably it's textbook ECG.
How we can use auto scale here?
Auto scale is this button here, oops, this one here at the bottom left. And if I click it, it adjusts automatically.
She is moving.
Auto scale again if you like. I could also just auto scaling is a nice feature in the research software. You have also constant auto scale, so it constantly auto scales to your signal. I was about to say we don't see the dyscrotic notch so nicely, but you can see it. You can't really see it. Nice. Sometimes you really get a little bit of, like, the background is maybe one thing also to mention, it's in this education software, all the filters are set. It's basically done to work ideally. In the research part, you can really set the filters, you can change the filters. You have low pass or high pass filter, or mains filter that filters out any 50 Hertz frequency from electricity grid or so. You sometimes even have, if you have fluorescent lights, you sometimes have some interference. And you can all manually adjust these filters in the research software. And for simplicity in the education teaching software, we have done automatically. Right. Should we have a look at the research software for a minute?
Okay.
Are you happy to stay attached a bit more? I'm also opening the ECG demo. So this is an example if you run an ECG study. So this is now, the example data is done on the rabbit. So this is an ECG of a rabbit, and if you tell the software what species it is, it always sets the automatic detection for the different parts of the wave, and you can see on the left hand side how it's calculated, where it's calculated the start of the P wave, the P wave peak, the end of the P wave, and so on and so forth. It puts all the data directly into a table. Maybe I'll increase this to show you a bit. It's hard to read, but you can probably see from the top line, it has the heart rate, it has the PR interval, QRS interval, durations, QT time, and so on and so forth. Well, thank you so much. The height of the amplitude, and so on and so forth. This is all included, automatically populated.
Can you export easily to the Excel or SPSS?
Yes, you can. The export function is so you have a ton of. You can export it into MATLAB or to EPS or to standard Excel, CSV, and so on. Quite often people do the analysis in the software and only later put making a nice table or something they export it. Because as an example, if you record a human ECG, we normally have a sampling rate of 1 kilohertz, so 1,000 samples per second. So if you take, means if you do, let's say, a 1 minute recording, that's 60,000 sample individual data points. Just imagine analyzing 60,000 samples in Excel.
Yes.
Probably not.
Yeah, so we can just, if we can tip like we can see how we can see the heart rate variability on the bottom. Does it work?
I'll show you heart rate reliability in a second. Just want to show the this one here on the right side. This one here is basically many ECG waves, one after another, plotted on a time scale. The color even represents frequencies that are detected, so it's a kind of a Fourier transformation plot. You can see on the left hand side, almost can't see much, that's a P wave, that's a QRS here, this one. And the interesting point here is probably during this experiment, either they gave a drug to the rabbit or they exposed him to something else or whatever, and then recorded over time. And you can see here now over time how the T wave shifts, so the QT interval increases. So that's also a way to, over time, look how it changes, not just a start point and an end point, but also over time until plot it in a very nice visual way. Here you can see all these green dots above the, green dots above the ECG. It's an auto detection, so the software automatically detects the QRS peak and calculates heart rate and so on from it. So yeah, and if we want to just do a new one, use the settings files. Take this one out. Oops. Let's see if we can see, where is it? Channel settings. Amplify 1, and let's maybe just do this one. Not live anymore.
Yeah, something.
We have the wrong settings.
Is the software you use?
Hmm?
Is the software you use?
Yes, and then we have the hardware. The hardware
But
is
it
the
looks
same.
like this.
Yeah.
Is this what I've seen? I've never interacted with the one that's interactive.
Yes.
So this is the one we're using in Kibble.
Or use the LD?
I think. But maybe the old, but this is the one I'm familiar with,
Oh.
not the one that interacts.
It's all, it is electrode is always the same, but this one uses the questions on earlier only. This one have no like questions.
Oh.
It's in separate sessions, I said quizzes.
The old ones don't
Yes,
have
quizzes by its own.
So we can't, for whatever reason, do it now and just loading it as a playback file to show you how it normally looks. So this would be how it, those I've not heard ECG, that's a rapid ECG now. So this is how the recording would look like. And then what you can do in this software, you could then, as an example, go to the channel settings. By the way, we don't need 8 channels, so it's a bit too much. Let's do 2, and for the second channel, we just do a so-called cyclic measurement and say it's from channel 1, we measure the heart rate, should be it. And then it does a rate, and we can even, if we want to monitor something, while we're seeing it, you can see the heart rate right away. That's instant calculation. That's nice if you do, in pharmacology as an example, if you have an isolated heart and do something and you don't want to look into the details of the recording, you just want to, with one eye, see, if I apply this adrenaline, if I apply this, how does the heart rate changes, you can just zoom it out and have it.
These features are in lab research.
That's in the research lab chart, yes. By the way, it's also so we also have a teaching version of LabChart, much cheaper. And don't tell anyone it does the same. It's just not license from the light. You know, we want to support teaching. That's why we make it cheaper. But that means theoretically you don't have a license to do research with it. But I won't tell anyone. Don't tell anyone. Don't record it. Okay. Yeah. I'm lucky that you don't have a 450 heartbeat. So that would be too much. Let's just have a. I don't know all enough, but let's have a quick look into heart rate variability because it was requested now. So this as an example is how you can do measure with on an ECG heart rate variability. The top one in the middle, this cluster, is showing you ectopic beats. So as an example here, there's just, in this case, in this example, there's just one ectopic beat. And if you click to it, jumps to, on the left side, it jumps directly to the region. So you can see, sometimes it's also, you know, the software can only analyze within the boundaries you set it. So sometimes it also does a miscalculation. So you can check it and see. And the left one is basically plotting the RR interval to the next RR interval. So basically between two heartbeats to the period to the next one, and then it's basically plotting the variability in this so-called Poincaré plot. And heard it. Below in the middle is on frequency of the signal, and on the right hand side you see all the, let's say, basic figures. I have to admit I know a bit about heart rate variability, but unless you want to tell us a bit about it.
No, I used to know every time you just want to have a certain parameters.
So the nice thing is there are a ton of preset. I mean, that's probably the thing I showed before, or that you've seen before. Let's just close it and open again. So you can see here all these different analyses that you could do, where we have preset settings files. What is at the bottom? We have spirometry. That's, you're doing it afterwards, or you did it? You did. You didn't finish. PV loop is pressure volume loop. It's, let's say, if you do animal research, that's something that people do to understand the relation if you apply drugs between pressure and volume of the heart.
At any time we can just apply the necessary accessories we need.
Say it again, sorry.
We can just buy the accessory we need. For example, we don't have any accessories, so we can.
If you have a power lab?
Yes, we already have a power lab.
And if you have the software, and the software, some of these are so-called pro modules. Quite often people bought the pro version in the first place and have them all. But we need to check. But some of them are for free and some of them are part of the pro. This is something we can check. But yeah, I mean, basically, this one is built for teaching because it has a stimulator, it has a bioamplifier built in. It's just one box. For research, people quite often buy a power lab that just have the 4 or 8 or 16 channels. Then they buy an amplifier and a bridge amplifier and this and that and a stimulator. This is basically all in one. So it's easier also for the students to use it, but it's also quality-wise can be used for research easily. It's really good.
Excuse me. Is this product open for individual purchase, or when one wants to acquire it, to go through an institution?
How do you mean it?
Like for instance, I as an individual, I want to buy. Is it open for sale to an individual, or it has to go through an institution?
Let's say we historically don't sell to individuals, but that's just because that's normally how.
Because of the price.
Yeah.
So can we have an idea of how much it costs in US dollars for one?
It's really hard to say. It depends on the setup and on how. It would be much more in Europe and in the US. Can't put an exact figure to it, but definitely a couple of thousand.
Give a price range.
Hmm?
Give a price range.
But including the software and so on. Sorry. But I mean, we would sell to individuals. Let's say if someone wants to do some research, we would. But historically, it's always been to institutions or companies or doctors.
But what if the individual has maybe a research grant and he needs to buy a
Good
powder?
question.
Wouldn't you sell to him then? It still has to come through his institution.
Yeah, no problem at all. So if it's so we don't have a problem selling to individuals. It's just in general, it's how to say it? Sorry.
Take your time.
I think the thing that individual purchases is
From my experience,
I remember it's quite costly.
such brand, it still has to go through the department and then just the procurement and everything.
Yeah.
Although it's
I
your own money.
think they have to wait because it has to be updated and it should be used. So if given to individuals, this will they cannot guarantee it's sustainable.
Just to give you an idea, one reason also is like tax implications, because if a company sells to another business and a university or a company or something like this is much easier from the tax and the import and export and so on, rather than an individual. So that's quite often, even if individual come with a grant, they normally go through the procurement of the university, makes it a lot easier. But yeah, it's time to flip the classes, I think.
Yeah, but we want to make sure that the other ones are.
Yeah. So maybe while she's checking, whoever wants to come front, you want to be free now?
We can't leave without appreciating him, so we have to jam our hands together too.
Thank you very much. Hope you like it.
That should be ready.
What was this priority?
So the next session will have 1 hour.
Okay, you have more time for it.
Just wait.
I'm in charge of showing you a little bit around ECG today. We will show on one hand and practically do it in our teaching software called LabStation, and at the end I can also show you a bit how much more powerful the research software is. But the main focus is really on teaching. You might have heard this name now. Maybe one of you even met him before, I don't know. Professor Tony McKnight, you met him. He really was an inspiration for us. ADInstruments was founded over 35 years ago by father and son. So the father was Professor Tony McKnight, physiology professor in New Zealand. And his son was an engineer who developed basically the first power lab. Because Tony McKnight, the professor, was used to do the ECG recording on paper, and then couldn't really do much about it. And then the first Mac came up in the 80s, right? The first Macintosh computer with a graphic interface. And so the idea was, why not bring the physiological recording onto a digital machine? That was the whole crazy idea. That was how ADInstruments is formed, and that's what AD stands for, converting an analog signal, an ECG, an EMG, a force, whatever, into a digital signal that can be analyzed and stored by a computer, the software. And Tony McKnight was an emeritus professor, and for many, basically until briefly before he passed away last year, he was traveling the world, and his passion was to, improve physiology education. He often traveled also to Africa. He had a passion for the physiology education in Africa, and he always said that he was convinced that the future lies in Africa, and we want to carry his legacy and help with this. Tony and some other professors developed an online resource called Understand Your Physiology. That's like, he always told me, don't call it a textbook, and I still will. Think of a textbook, putting it into an interactive, exciting way of teaching. That's what he did. Asking questions rather than telling students what to learn. Using questions always to engage students. If you think about your children, that's how they learn, right? They constantly ask why questions. That's how they learn. They don't, even if parents want to think this way, but they don't learn by you telling them what to do. They learn.